Okay, I just realized the previous stream that I started, there wasn't any sound, so I got sound now. And let's go over what I did. We're just going to get reacquainted with this code base, since Shader Toy seems to be a little bit broken for me. Maybe I just don't know what the hell I'm doing, but either way, I'm not going to waste time trying to figure it out. I'm just going to move on and work on something else I can work on. So, Paint 5D class, we have, it's not really a class, we divide everything into data and functions. So on the left will be the data, and on the right will be the functions. And if we need to look at the function code and see the function documentation, we can open up this tab, and this is going to be all of the documentation for the functions of all the different sub-libraries of the project. If we're looking at the data and we're trying to figure out this data and we want some data documentation, same thing, we can go to the data documentation and kind of see, well, what's up with that, right? And when we're just trying to code, we can keep up the source code for the data and the source code for the functions, and then we have a good way to see everything that's going on, right? So I've seen other people kind of code like this, where they have the header and the implementation, and that's, you know, that's kind of a similar thing that I'm doing, but I'm just dividing everything differently. Everything gets divided into data and function files. Okay, so first thing I want to do is I want to still clean up some of this stuff. So I have like this big pattern breaker comment here, and if we open up some more of the documentation stuff, I have a summary section here for different systems, and I see that in GPU data we have a pattern breaker hashtag. So I also want to I think I want to change this pattern breaker to namespace pattern breaker. Just because I think that makes more sense. So namespace pattern. Right, so let's just add that. And you know, just a little note about, this is just a summary. Full namespace is AAC2020 GPU data, Paint 5D, right here. And you may be expecting AAC2020 Paint 5D, right? So I've kind of, I think I might end up totally regretting doing this, but the idea was to make it known that the Paint 5D was kind of a is kind of tightly coupled with the that Paint 5D is tightly coupled with the GPU data, but I think I might regret that decision, because it kind of wrecks with the normalization of like how I've been doing everything else. So I think I'm not going to do that in the future. I think that was a bad idea. But I don't know. We'll see. I do kind of like that it kind of lets me know that relationship, but I don't know. So if we look at the comment over here, this is basically the same comment as in here. So we're going to take the namespace pattern breaker, and we'll just do we'll actually give that a more unique tag. And the other thing, so let's just remove this, right? So let's remove this, and let's just put in a little hashtag comment, you know, namespace pattern breaker, Paint 5D, right? So we have a little comment that kind of tells us that there's something up with this, right? And when we're looking at, we have a section for documentation for all of the hashtag type comments. So in this _H, I have all these kind of like hashtagged comments, and I think that this this namespace pattern breaker Paint 5D should be actually taken and put into here. So we want to keep the summary code, the summary comments, we want to keep pretty short and allow any like elaboration to be in this other file, right? We want to segment everything so that we can eliminate a data overload or ignoring a whole bunch of stuff, right? Because we don't want to overload a new user to the project, and we also don't want to have so many comments in the code that after you're familiar with the project, you're just annoyed as hell because you're like, I already know this stuff, but the comments are like getting in my way. So we're going to take namespace pattern breaker paint 5D, put it there, and when we put hashtag pattern breaker, we'll say that we'll make a note that about what that is. So breaker is a warning to reader of code that something about this code breaks the conventions, patterns, typically used in the code base. Right? So just a note of when I say pattern breaker, what I mean is that, you know, when you're new to a code base, you kind of like search for these patterns to try to figure out how the code works. And therefore, when something is breaking a pattern, we want to absolutely know that, you know, we've broken a pattern and just warn that we've done it, right? Ideally, we should just be as consistent as possible, but, you know, we're going to do things, so let's not fret. So now we have a pretty simple summary for GPU data paint 5D. The other thing is, do we really want this df, or is that just visual clutter? Should we kind of clean that up? So I do kind of want to clean that kind of stuff up. Now these are summaries, so I do like the idea of like having, right, for functions you have the F's, and for data you have the D's, so you can obviously see what file you're in without actually reading it, without actually reading the file name. Hashtags, well, there's obviously hashtags, so you know you're there. So I don't want to mistakenly edit the wrong file because I at a glance, you know, I get this tunnel vision and I don't realize I'm in the summary stuff, and then I end up doing stuff wrong. So so I do like D plus F, right, because it's a summary for data and functions. However, I think maybe just S for summary might be a little bit easier on the eyes because there's not those alternating letters. It's still kind of visually cluttery, but I think that is better than what we had before, right? And let's not get too crazy with section dividers unless they're absolutely needed. Right, let's try to reduce our subsectioning, or use some indentation to communicate that, and just kind of keep these sections kind of small like that, right? So I do think that that's pretty good. So GPU data paint 5D, about user canvas data for paint5d.exe, and so that's for when we run it as paint5d.exe. So we have a hashtag comment, override default shader 001. So what we're going to do is we've set up the project so that it has 9 different shader slots, right? You press the buttons 1 through 9 and a different shader is activated. And what we're going to do is as we work on this project and we need different renderers for different systems, we'll just associate everything with a one-to-one relationship to the different keys on the keyboard. So if I press 1, I'll I'll be using Paint 5D data. I'll be using the Paint 5D editor. I'll be using the Paint 5D rendering code, right? So one-to-one relationship between everything. And the reason why we're going to do it that way is because when we start doing like these one-to-many and many-to-one relationships, or it starts to get really confusing, especially as you start to add more components, right? Like, let's say you have 4 components, and some of them are one-to-one, but other of them are one-to-many. Like, it can get really complicated. Like, let's say, like, let's just draw a little diagram. So maybe we have some data, and render editor 1, I don't know. So imagine like editor 2. Let's call this editor 1. So E1 data, E1 render code, E1 user input, and then like E1 tile brush, right? And so there's like there could be like a paint brush kind of tool that you're using in the editor to set and remove tiles, and the renderer will interpret the data differently. Like maybe you have different ways to interpret the same data. So what you could do is you could say that maybe editor 2 is just maybe editor 2 maybe let's say editor 2, let's just do editor 2 like this. So imagine that editor 2 is just supposed to render all of the data that is here. It works on the exact same structured data set, but it tries to interpret it in a slightly different way, right? And so you're thinking that maybe editor 2 data and E2 data should like commonly share this one piece of data, right? Because they kind of like, because it's just rendering it differently, right? And then for the rendering code, the rendering code is not shared. They're unique pieces of rendering code. The user input, maybe that is, maybe even these things are the same, right? Maybe the user input is the same as well, right? So, but the render code has to be unique, right? Okay. And then tile brush. Okay, now let's say we have a third editor where we're kind of like interpreting the data in a completely different way, such a different way that the bytes of every pixel in our texture memory that we're kind of rendering, well, they mean totally different things, and we've segmented it differently. So the tile brush class has to be different because maybe in these two editors we were using tile values 0 through 16, right? And the render code here, these two different pieces of render code, they just render those tiles with different colors or different textures, right? And they use the exact same data. So let's say that this also uses the same data, and it it renders it differently, but it also kind of interprets that data so differently that this tile brush needs to be unique, right? So this isn't connected either, right? So now you have for the rendering code for the different editor. So everything here, consider this editor 1, right? This is editor 2, and this is editor 3. With rendering code, it's always a one-to-one relationship between a unique render code and a unique editor. And then with the data, right? The data right here currently is a one-to-many between data and editor, right? So the data, it's one set of data that is going to be used with many editors, right? And then in our tile brush here, we have kind of even more confusing. So it's one tile brush to many right here, but then this tile brush is unique, so it's like a one-to-one with this, right? So so it's not like so when you're thinking in terms of like SQL one-to-many and many-to-one, I think this just could get really confusing, right? And then maybe eventually we want to, instead of rendering two-dimensional tiles, we want to do some type of voxel engine rendering. So we need like a new set of data, because that data is completely different now. New data, new problem, basically. And so now all this is unique and not associated with any of this. And so now we had a one-to-many relationship here, but now we've broken that relationship here. So everything could get really fucking complicated. So rather than try to figure all this out, what we're going to do is every editor gets unique data, it gets unique render code, it gets unique user input interpretation, it gets a unique tile brush or whatever type of tool it needs to associate with editing that data. Then if we have some type of relationship where, say, this tile brush and that tile brush are pretty much identical, then we just need some code that says when we swap from here to here, we'll just copy the state of this tile brush into this tile brush, right? And so any of the weird relationships here that need to be managed, we will manage those in the swapping between the editors, right? And that will just be a convenience thing, right? So that if your tile tool has certain settings, you might want those settings to persist when you switch the view, right? You don't want your tools to all of a sudden change just because you like you switched views, basically, right? So maybe this is like a opaque view and this is like a wire map view, right? Then you don't want your tool to change drastically just because you switched views, right? Maybe you're setting tile number 1 here, and you still want to be setting tile number 1 when we switch to this editor here. So we'll have code that kind of like copies things over if there's some type of shared state. But we're not going to share the state in the code. So we're kind of sharing the state, but not in the sense of one memory location, right? So we're kind of going to be wasteful and just have duplicates of the state so that we can keep a one-to-one relationship with every single editor and just keep everything as simple as possible. And that's the same thing with this data. So this is a 512 by 512 chunk of data, and if we want to switch to this view, and when switching to this view, it's supposed to be a view of the same exact data, then we're just going to take this data and we're going to copy it over, right? And that's a little bit wasteful, but that's how we're going to do it, just because we need a system design that we can wrap our head around. And it's better to make the code a little bit inefficient than to make something I can't wrap my head around. And then we can always try to optimize that later, right? We could eventually, we could have some type of, this could be some type of virtual data object, and this could be another virtual data object, and they both point to the same, like, core object, right? But that would be, like, a consideration for much further down the line after we're like, shit, we gotta optimize this, right? Right, like eventually all this stuff could be like, the data object could just be bounding coordinates on a giant megatexture, like, right? We could do that eventually. But conceptually, we want to keep everything as simple as possible, so we're not going to do this, right? We're going to even if there is shared state or shared state or components, every editor should get unique copies of things to keep the relationships simple, one-to-one relationships. If two editors need to share the same tile brush, we just copy over Okay, so this is basically what I'm describing here. We want to, we don't want to do this. This is bad, right? So below, this is right. So this is bad. We don't want to do this. Okay, we do not want to do this. This is good. And then the good option is so the good option is just saying instead of having this, it's just no lines between anything. It's one-to-one relationship, you know, E1 data to E1 user input to E1 tile brush, etc. And this is just conceptually what I'm talking about, right? So there's nothing called exactly these things in my code, but this is conceptually, you know, what we want. Right? Conceptually, this is it's a 1 to 1 to 1 to 1. Well, okay, 1-to-1 relationship for 1-to-1 to 1-to-1 relationship for each editor. And if we add some other component that needs to be in there, same thing, 1-to-1 to 1 to 1-to-1, right? And sometimes there might be some editors that maybe this editor has, you know, 1, 2, 3, 4 things, but maybe there's another editor that needs like 5 different components, right? And so right, so that would further complicate this kind of web of stuff. So that's why we kind of want to keep on thinking of stuff like this. And why was that even getting into there? I think it was because I was saying about how the every editor gets a 512 by 512 GPU data chunk, and that's kind of why, right? So let's take this kind of thing we worked on here, a little explanation, and let's go into our hashtag comments, and we're always going to put the newest comments at the top of the files. And the reason for that is just so we can kind of get a good history of when we did certain things and when we had certain thoughts. And that'll keeping some type of chronological linear order is very important to me. I think that it's very easy to nest things and branch things, and that can help for dividing and conquering and searching for things. But when it comes to like figuring out where you were in the code, or when it comes to like digesting data and knowing where to start, like having something completely linear is better. I think branching can become overwhelming, and I think that in our current age, the challenge is not about branching data. It's about taking data that branches and turning it into a linear format, right? So like the World Wide Web, all of your files on your computer, all the things that you do, you know, you can't figure out where you were. like finding something you did last week can be almost impossible because you don't have a linear list of everything you did from now till a week ago. So same thing here, all the code will be branching around into different files, but we want some way to linearly organize things so we don't get lost or that we can get our bearings quickly. So 1, 2, 1, editor, 1, 2, 1. Yeah, so editor one-to-one relationships is what we'll call it. And then over here, we can have that, right? So every time we see a little divider line, we know we're in a different section talking about something different, and we can just organize those thoughts. And also, project is editor-centric. As we Okay, so this project is going to be editor-centric. So this is from my experience shooting myself in the foot. And I also think that Doom, I've seen John Carmack demo his idTech engine, and it looks like they kind of share the code in the same way, where you're kind of like editing geometry in-game. And we want to do the same thing, and it's just because we don't want to fractionate our code base, right? I don't want to create like tile map rendering code for the game engine and then have to create some more tile map rendering code for the editor, which I have done before, and then you have this nightmare of things just don't sync up correctly. You end up with things where it looks slightly different in the editor than it does in the game, and that's just it's a nightmare. So yeah, you got to write everything twice, and not only do you have to write everything twice, but you have to make sure everything agrees with each other. It's not cool. So project is editor centric, right? As we build a game, we want the game to play just. Okay, let me read this. As we build a game, we want the gameplay to just be an editor view where the user's controls do not allow for editing the level, but rather just moving and controlling the player. Level is still mutable by things like destructible geometry, but not by editing tools. Doing it this way means we only have one code base to maintain, an editor code base, rather than a game engine and level editor code base. So that makes sense to me. And we'll just keep on taking notes as we're going and kind of cleaning stuff up here. So let's go back to, so this is our data side. Let's look at our function side. We moved that. This is just a halt function. Halt is typically the first function, and that's not really a hashtag. I guess we could. Yeah, halt is typically the first function. Right. This is just like a section divider with an informative name, right? So for every sublibrary, we're going to typically have a halt function at the top of the file, and that's so we can kind of like it's just so it makes it easier to find where things went wrong. Now, I think that this is kind of like this is kind of ugly. I feel like we could condense the space a little bit if we if we were more terse with our error message rather than trying to do this. Like, let's try to conserve our space a little bit more. So let's get rid of this printf. And I know that we want to know it's fatal and we want to know where it came from, but you know what? Screw that. Let's just say fatal 2020 1204 076 p.m. Which might be confusing to people who, you know, and we'll just keep it like that, right? So we'll just keep it as something that we can click and find it right away. And the idea is that when this token shows up in the code, I can just find it and it's going to be unique. The idea is that we don't want to go over this column limit. If we go over this column limit, we have to start wrapping the code, and we start wrapping the code, we end up being like really inefficient with our space. So I think that we should be a little bit more compact than we've been being, and just make things kind of like, yeah, just be more compact about it. So with that, let's just you know, unless it's really important for us to have some type of formatting, I think that sometimes just formatting things in a very terse kind of way is probably for the best, right? If we don't really have to like wrap our head around the way it's done, then it kind of makes sense to just be like, you know, just throw it in there like that. Let's not worry about it. Let's, yeah, the formatting is horrible, but really all we need to know is this is like a halt function, and we just really don't want it to take up that much space, right? Sometimes the amount of physical space that code is taking up is, it's more important that this takes up less space than it be, properly formatted and nice like this, right? Just because this is something that's used quite often, I just don't see needing to do that. Now, do we want to go crazy like that? And I'd say no, because we still want to be able to quickly visually parse and see the different sections. So I think that that's what we're going to do. Maybe if we want to, we could put the void up here like that. I don't know. But we just want a decent amount of white space here and here. Okay, so let's look at the next section and see what we have here. So define U32, define air. So we have these defines. I do like sticking the defines here like that. That's a pretty good pattern. Now, why are we doing air? Well, I guess this makes sense because we're saving a lot of space by being able to keep these error messages nicely packed in there. So I'm not against keeping the formatting like that. Putting the return type above like that is also helpful, because then I can, the first thing I see when we indent is the name of the function, and also if the type up here is like really long or really short, it doesn't change where this name is relative to the margins over here. Okay, so So this pixel name here is kind of like we should indent that. So the pixel name is Paint 5D, but we're just putting it in a char array, and we can't just do an assign like this. That's effectively, we want just an assign like this, but because we're putting in the char array, we're ending up with problems like this. Now, all the systems that we're using, we're going to try to keep all of our systems to exactly 7 letters, because everything just lines up nicely in the code when we do it that way. And then also, when we're thinking about the names of these different chunks of memory, we can use exactly 8 bytes in a char array, right? 7 bytes for the name, and then a last byte for the null terminator, right? And I feel like that just works out nicely. Now, let's see what else we have. These errors could happen if you fail to zero initialize struct, you fail to call initializer twice or more. So why? So I'm going to make a little hashtag with the date, why paint 5D errors 2020 12/04. And then what we'll do is in our hashtag comments here, we're just going to keep on offboarding stuff into this section here. Right now we can't, even though this isn't actually a source code file, I want to format it as if it is a source code file, so we have to get rid of those multi-line comments because of the you just can't nest multi-line comments. And then what we can do is we could take this and we could just kind of like put it in here like that, and that way we have a reference to like what the hell we were talking about when we put that, because this code block might change and then this hashtag might not be relevant, but we're going to try to keep a good record of what was going on, right? And yes, that does mean that, you know, some comments will eventually be like out of date, but then we can just, as long as we put these comments, you know, as long as we put all the new comments at the top of the file, then we can think of old comments as just history, right? So, right, the maintenance of the comments in the code can kind of suck, where like, oh god, what if the comments don't match the code? I'll never write comments in my life because, oh god, what if they don't match the code? Blah, blah, blah. To avoid that kind of problem, we'll just, as long as we linearly shove all of our comment thoughts into here like this in order, we just have like a linear history of what was going on, right? I labeled this with a date just because I don't want to do E1, E2, E3, E4 in the hashtag because I feel like that could change. So we'll just comment it like that. So let's go back to let's keep this blank as long as we're not. Actually, you know what we'll do? Let's open up the hashtag comments on the other side as well, right? So that we have it in both editors and we can look at it on both sides. So that way, when I'm over here looking at this Paint 5D stuff, hold on, and language. So that way, when I'm looking at the Paint 5D stuff over here, you know, we can see this hashtag over here, and then we can see the related hashtag over here in the other editor on this side, and see the relationships, right? So we're always going to keep the data on, the data code will always be on the left, and the function code will always be on the right, and then the opposing window will always have the comments for the source code that we're working on, right? So the goal here is just to kind of remove a lot of these comments so that we have an idea of what the hell is going on, right? So allocates OpenGL texture, init instance. Okay, sure. Now, oh yeah, GPU data init instance. Okay, that's fine. Now, is GPU data init instance, is that actually a thing that is done, or did I just kind of like stub that in? Because I feel like we probably didn't initialize that. So if we look at GPU data functions, right, and we go Control F, and we look at init instance, like, so we actually have that as a vital to-do right here. So the vital to-do is a to-do that, it's not like a to-do where you're like, yeah, someday I'll add this feature and then you never get to it kind of a to-do. It is a to-do more like a must-do. You absolutely need to do this. So what we're doing is in parts of the code that we left unfinished that absolutely need to be finished, we put this marker in here, right? And then in the code, if we go into the root of this library, so we're in the root project, right? This is the root of the project, and we open the only C11 file in the whole project, right? So it's trying to help you funnel into, like, if you're new to this code base, how are you going to know where to start? Well, if you open up this C11 file, we chose very carefully what was important to put here first. So first we have kind of like a expectation breaker of how we're going to organize this. So we have some documentation for what is like a library chain, and what do I mean by procedural OOP, and I mean data then functions. And also, if you're used to C code, you're probably used to a .h and .c file, so I want to be explicit that no, this is not what we're doing. We're not doing a header and implementation. One exception is the this file that is .c11, so that's kind of like a .c file. But yes, what we are doing is we have .d underscore for data, we have .f underscore for functions, and then we have .p underscore for public interfaces, which is sometimes there, but not always. We always have a data file and a function file. The reason that they're just underscore is because I'm just getting sick of file name associations, so just screw it. And also, it kind of helps you realize that in C code, file type does not matter. It's just everything is text, right? It's all text, right? And so this is my way of saying fuck file type. File type doesn't matter, right? It's what it means. It's what it means to you. And also, it does actually need to be source code, I guess. But so the first thing is just the library chain order summary. So when we build this project, we can compile up to one of these levels. And what we're going to do is we're going to write this project by slowly layering on different pieces. And the goal is that if I compile up to 8, I have a working project. If I compile up to 13, I have a working project, right? If I compile up to 15, I have a working project, right? The goal is that no matter what layer I compile up to, I always have a working project. And the reason for that is eventually we may get some we might make some horrible mistakes, like memory stomping or weird things with threading and just like really weird undefined behaviors. Right? And undefined behaviors really sucks because things will not crash in a predictable way. And so if we start to get like weird behaviors, it might be really helpful to start to subdivide the project and to eliminate some of the variables of what could be causing the problem, right? Now, some things don't need to be in the order that they're in, right? So we've enforced a linear order here, but that doesn't mean that that all of these are direct dependencies of one or the other, right? But by the nature of code, things need to eventually end up in a linear order. And so rather than solve things with some type of like dependency injection, or we could use include guards, right? We could use an include guard, and we could just leave it up to the compiler about how to include things in a different order. Now, I think that's a bad idea. I know how it's nice and convenient, but having that sanity of mind of knowing the exact order of all of the source code is going to help give me some sanity of mind that I know when I compile up to 15, all of these libraries are in this exact same order. If we did some type of dependency resolution, maybe when we compile up to Paint 5D, it brings in the dependencies one way, but then we slightly edit one of these source files, and then the dependency is resolved in a completely different way, right? So we don't want to, right? And that could be possible, right? Because like I said, like this this dialog user interfaces, the only thing that this depends on is this window here. It doesn't depend on any of these things here, right? And because of that, right, that means that this could potentially be put like over here, like, right? Like things could be put in a different order, right? The exact ordering of this could be changed without wrecking the project, right? Because it's not this depends on that, that depends on that, that depends on that, right? It could be, it's more like, for example, GenaWin. This GenaWin depends on specifically this group of things right here, right? And then this group of things right here depends on this, right? And so this group of things right here could be shuffled around, right? We could have editor, mousebox, keybox. We could totally flip the order of this, and everything would work fine. But we need to have a definite order so that when you're looking at the code, you have a high-level overview here of how everything fits together and how the project was built up. So you have like a sanity of mind of how everything was put together, and you also kind of have a history in a way of like how did we build this project up from the ground, right? And we can see that things further in the back are kind of like the foundation, and we abstract on top of things as we go to get more and more complex behavior. So that's why we're doing it that way. Anyways, that's a rant. Let's get back to the vital to-do that we have highlighted right here. So right here we can see crash on vital to-do, and we see that it is set to 1. So that means anywhere I see a vital to-do, it's going to immediately crash, right? And that's the second piece of configuration that we can use, right? So this is how far we're compiling to, which is 15. So we're compiling the entirety of the project. And then here, if we haven't touched this code in a month, which actually I have not touched this code in a month, we're going to need to know where we left off. So we just set this to 1, and then any place that we use a vital to-do, we're going to have a message that just crashes, and then we know, crap, this is where we left off, right? So it's like this is like for an RPG analogy, like an RPG game where like you haven't played it in a month and you have no fucking clue what to do, and you can't beat the game anymore because you don't know where you left off, you don't know what the next task is. Well, an RPG game is a hell of a lot easier than writing code. So, if you can't beat a game because you don't know where you left off a month ago, then imagine trying to finish a piece of code where you left off a month ago, right? Good luck, right? So this is our little savior to help us figure that out, right? And some RPG games, like newer ones, do have some type of mechanic where, I think in Grand Theft Auto, right, you can just go to the phone booth and you can figure out what the hell you're supposed to be doing. So, you know, having some type of objective marker in our code to let us figure out where the hell we are is going to help, right? So then we have some top-level code. This is basically our build system, and we have 2 pieces of the build system. It's just all the macro logic and include logic that controls this, right? This is a high-level overview, but where we piece together all those systems and all those files is tucked away in here. But we want to not overload the user with too much information when we're just opening up the main project, right? So then the main function is divided into a data file and a function file, and that's also within the root folder of the project, because that's also another thing you're going to want to take a look at right away when you're getting acquainted with the code. And then the about this project, this was in a different section of code, but then I'm like, you know what, it should probably be in here because it's kind of like an overview. And I put the comment at the bottom because I realized that, most people don't read comments, so I kept the commentary as short as possible and just stuck to the most important stuff, which is the expectation breakers, like how you need to think about things when you get into this project. And then this is just a tree-style conceptualization of how the code works, right? Because, like how I said that things can be organized in different orders, so we have these bare basics, and these can be included in any order, right? Load PNG, and then my pebwalk library. Then we have some other things, so we have these pluses, so all of these can be in any order. They don't depend on each other, but all of these need to come before the next layer, right? And so this GinaWin, the Windows library, that's going to depend on these layers here. And the dialog user interfaces kind of depends on GinaWin. And right, so this is the Windows and dialog section. So this is the next layer of everything, right? And so now we have, this is taking from old code. So I know specifically that I need these type of pieces. So if we are going to eventually have OpenCL and Vulkan, right now we only have OpenGL bindings. We're going to also need OpenCL bindings, and we're also going to need Vulkan bindings, and then we're going to need at least a third coupling library that manages the interop between the different libraries. So there used to be this thing called COG in one of my old libraries, and it managed the CLGL interop. I gave up on CLGL interop because it was just painfully slow, and so I'm going to try to write all of my stuff in just GLSL shader code, and I think there's a lot of good stuff we can do with just GLSL shader code, and I have this rendering idea. I don't know if we can, I don't know how, I don't know. I had this idea of how things should be rendered, and conceptually I thought the algorithm made the most sense doing it in OpenCL, but the thing is that OpenCL, OpenGL interop just does not work well. The other thing is, OpenCL seems to be, I could be totally wrong, but it seems to be going the way of Flash, where you look at it and you're like, I don't think it's a safe bet right now. Like, I really like how OpenCL is a lot simpler than Vulkan, and I like the model of how we could create these, how we can kind of subdivide the space very nicely. Like that space subdivision works great for the tile-based engine stuff that I want to do. But the thing is that I just don't think OpenCL is a safe bet. So even though, I was considering all these different technologies, OpenGL, OpenCL, and Vulkan, I'm going to go with OpenGL. And the reason is Vulkan is, it's too advanced for me. I've read a lot of the spec, like a few hundred pages of the spec, and it just goes over my head. Because I just don't know enough about graphics programming to digest that type of stuff. I've written some basic Hello World Vulkan projects I've written more than one Hello World Vulkan project to just get it up and running, and I just ended up writing a whole bunch of crappy C code that I ended up throwing away because I just didn't like the organization of the code. Writing a project in a way that is maintainable is just really hard. You come back to it in a month and see how well you can get back into the project. So since I haven't touched this code in a month, this is kind of the test to see, did I write it in a decent style? Did I use a good organization strategy, right? Do I have the right balance between coarseness and granularity, that kind of stuff. So down here, so we have CPU uniforms. And so this is where we're going to store all of the so this is where we're going to store all the uniforms. So initially I just wanted a basic gradient quad, and then we're going to add uniforms on later, right? Just a dead simple shader that doesn't even use uniforms. and that was the way I initially built this up. But then we ended up with these just weird interlaced dependencies with the way everything had to go together, where we can't really do a gradient quad and then later add on uniforms and then do more complicated shaders. The pipeline code just becomes spaghetti code if we do it in that order. So therefore, we put the uniforms code for like where are all the uniforms. If you want to know where a uniform for a certain shader is, you want like an index of all of that. It's going to be in this library, in this sub-library. Then to get the gradient quad working, we're going to do this. And then this was removed because basic uniforms was put before the gradient quad. So this used to be called, so we did like a name change as well. So C CPU info, all right. Anyway, so then after that we have this frag bed, and frag bed is well, actually it kind of has a little detail what this is. One, creates shader toy-like program we could sell. Shaders 1 through 9 activated when pressing keyboard. Can override shader code by editing serialized frag bed frag files. So what this does is it once you compile up to here, the shaders 1 through 9, shader code 1 through 9, will be used depending on if you press the number keys 1 through 9 on your keyboard. And so now we have these 9 slots that we can write shader code for. Each of these shaders comes with default shader code, and that default shader code is saved to your hard drive. If you edit the next time you run the program, it'll check to see if those default shaders have been saved to the hard drive, and if they have been saved to the hard drive, it will load from the hard drive, and if they haven't been saved from the hard drive, it loads the shaders from the source code. And what this enables you to do is it enables you to mod the game we're working on, because all of the shaders are going to be dumped into a mod folder. So if we look at this, because we already have it, so if you run the executable, it creates this mod folder, and inside this mod folder, we have all of the different default shaders, right? So shader number 1 is going to always be for keypad number 1, but we've kind of renamed it because now it's been reserved for something, right? So all of these shaders haven't been reserved yet, so I gave them these names in the source code. And then as we build upon this project, we're going to change, we're going to still keep shader 00 with the number, but then we'll change the ending suffix about what subsystem it's for, right? And that'll just make it really easy to know what's going on here. Like, we want to be able to connect the code to the actions you're taking in the editor. And we're going to keep it just dead simple, right? So, this could be a problem eventually, like, where it's like, okay, well, now we can never use these hotkeys because, they're reserved for these different editors. But we're just going to grandfather in those 0 to 9 keys for these different editors, and then once we have a game we can sell, we'll have to have some way to disable or override the number keys for the gameplay mode. But for now, until we actually have like a good product going, we're going to just keep it dead simple, because I did a version of this code in JavaScript, and I got pretty far. But when I came back to it a month later, it took me a really long time to just figure out how to get to the different shaders and things because of because I couldn't figure out the key press combinations to get to everything. So we're just going to simplify that and keep it a lot simpler. Okay, so let's go through. So now we have this next section. A minimal viable proof of concept engine will be compiling up to Paint 5D. to create an executable like MS Paint 95 that allows 5 dimensions, color, tile X location, tile Y location, tile size, and tile layer. So let's say GPU data is the struct, pix name, pixel data names, and then GPU data paint 5D. So this is just letting me know, so this, we're compiling up to paint 5D, so this is the next section, right? This is the next section of the project. So that all makes like really good sense, and I can kind of get a good idea of where we're trying to go with all of this. Okay, so I'm happy with that documentation. I don't feel completely lost and totally overwhelmed with this code, even though it's been a while since we looked at this. So let's go back to some of this code. So we were just trying to see if that init function was right. We wanted to check out if that init instance was actually filled out, and it's not filled out, but it's okay because we have this vital to do, so we're not going to forget about it, right? So then error checks, so strcmp, we're looking for the pixel name and paint 5D. So it looks like we have lined these up so that we can see that those two are equal to each other. And remember that the pixel name is actually just a char array, so if we want to do a strcmp, we got to take the first character, and we got to take the memory address of the first character, and that's how we're going to do this comparison. So now, the reason why we have this comparison here is because I want to make the code as easy to follow. So even though each one of these, every time I make like a memory chunk that's going to be used for something, it's going to be an instance of a GPU data class, right? So it's going to be an instance of GPU data, and every instance of GPU data is going to have a unique pixel name, right? But then I also want some type of way to have like a high-level overview of what are all the chunks of data that I have. So in AAC2020 Pixname Paint 5D, that's where we're going to keep that high-level overview of all the different memory chunks, right? So if we go into the pix5d, right? So let's go our pixname, right? Pixname.data. We can we see way too much commentary here, but we also see these names. So paint 5D, and then we have like a to do and a to do, right? And so the thing is you know, we have this library chain structure where we're trying to layer things on in a very definite order, and just once we finish a certain layer of the project, we want to forget about all those sub-libraries and be like, don't touch them anymore. Just add another sub-library if we want to add more functionality to the project, right? Keep this very layered, linear approach. However, so this kind of breaks the pattern, and I think it even says pattern breaker. And the reason why we're breaking this pattern in having this basically knows about things in the future, right? So, because paint 5D is declared further in the future. But the idea is that we want some type of piece of source code, right? Not comments, but actual source code that can self-document the pieces of memory that exist in the game, right? So by having this pixname file, we can keep an index of like all the chunks of memory that exist and what their names are, right? And then we can just have a high-level summary of like all of the data in the game, right? And that's going to be important. And I'm trying to do what I think is data-oriented design, or maybe I'm just throwing around that word, but I've watched a lecture on somebody talking about it, and I've actually watched more than one lecture, so I think I have the philosophy of data-oriented design. Maybe I don't have it quite right. I'm not an expert here. There's plenty of people smarter than me. But yeah, I am trying to keep everything in a very data-oriented design. So let's try to keep on cleaning stuff up, and as we go through everything and we look at everything, we want to just clean up the mess that is there. So this big comment here is probably going to go in the summary. So do one thing and do one thing well, a centralized place to know where the names that identify different 512 by 512 pixel chunks of memory that exist on both the GPU and CPU. So that is a good summary. We might also want to know that they're GPU data instances. Pattern breaker. This somewhat breaks the spirit of our libchan library pattern of adding things as you build up. Right, we talked about that. The variables here will only be used for human reference and asserts. Okay, well, that's important to know. So that it's basically just an enforceable self-documentation is what we're doing here. So let's see what else we have. It will never be used as an assignment like .pixname equals this, and we can't even do it like that because it's a char array anyways. But rather will be used like so. Yeah, so it is used like this, even though we have to do it a little bit more convoluted because of it being a char array rather than a string. But the essence of this is good. Reason: make the code easy to follow with minimal indirection while still having the benefit of a centralized area where all of the different 512. Okay, so what we're going to do is we're going to break this apart, this documentation apart. So let's go into the general summaries here. And this is the pixel name summary. So mostly what we're going to be doing today is just reorganizing the code and figuring out where the hell we are and cleaning things up and just making things a little bit easier to manage by not having to wade through all of this commentary, because I am very verbose and I think heavily documenting your code is a great thing to do, but you also don't want to, we have some limited screen space here. It's even more limited now that I'm trying to do streams of the code we're working on. So what we're going to do is, what time is it? 8:31. So, let's, I gotta go upstairs really quick and make sure my food isn't burning because, my mom said she was sharing the, what do you call it? Sharing the stove with me, so they might have turned up the temperature and I might have a burning pork chop, so I gotta check that out really quick. It's worrying me. Alright. Okay. It's not burning. It's not burning. I turned down the temperature, though. Okay. Sorry, I'm back. Okay. So pork chop didn't want it to be burning, so yeah, I just didn't want to burn my pork chop in the oven. So let's keep on reorganizing this code, and then eventually, not today, we're just gonna organize the code, get our bearings, right? Because if we, I haven't looked at this code in a month. Literally a month I haven't looked at this code, so we gotta since I haven't looked at it in a month, that's the best way to get fresh eyes on it and be like, did I really organize this well? And you forget about how the code worked, you get overwhelmed, you can't find the things you want to find right away when you are looking at the code, and it just, yeah, taking a break from the code and getting back to it really helps you figure out if your code is written in a way that's going to be conducive to for new people to like figure out where they are. Hold on, okay? So let's fix this. So this is the pix name. So we're just going to call this section over here, we're going to call it pix name, and .d plus f, because we're going to include notes for both the data file and the data file, as well as the function file, right? And that does look a little bit, this does look a little bit busy with having like all these S's, but I do like that I don't want to accidentally make the mistake of I'm editing the summary file, but oh, I'm not really editing the summary file, I'm editing this documentation file. So by having F's for the dividers for the function file, S for the dividers for the summary file, and for the data file summaries, we have D's. I think that just really helps me not make stupid accidents, right? So I'm going to program the code as if I'm a complete idiot and make really stupid mistakes, because that seems to be what I do. Let's take all of this documentation and throw it into the summary, or actually no, we'll take this part. We don't want to keep this, the summaries need to be summaries, right? So they need to be short, right? So we can still keep the do one thing and do it well tag, because I do like the idea of doing one thing and doing it well. So that's good for me. I think that would be helpful. Just say GPU data.pixname, right? That's what we mean when we're talking about this. We're talking about the GPU data. So example. Yeah, just keep a little example. Let's not go too crazy. And then over here, in here, we're going to say pattern breaker, and we're going to do pattern breaker pix name, right? So we're going to have we're going to keep that comment specific to this file, and then over here we'll just make a little hashtag pattern breaker pix name like that. Okay, and then we can take all of this code and we're gonna put it into our hashtag comments, right? So hashtag comments looks like the same right now. I have the same file on both sides, so we'll paste that right there. We'll save it. Obviously we need to reload, make sure it's the same on both sides, and let's just clean this up, right? So this needs to be cleaned up. So let's reformat this to the way it's going to need to be for this code file, right? So we're just going to create our divisions using these hashtags or pound symbols, whatever you want to call them. And then we will get rid of like all of the decorativeness around here. We don't really need that anymore, right? We can just clean that up. And these little white things are kind of bothering me. I get why I did that, but oh boy, that's ugly. Pattern breaker pix name. Yeah, we can just we can keep pattern breaker. That's fine. And we can also make a note here that we can go into. Oh, let's close that. We can go into the documentation here, and we can make a note that where it was extracted from, right? So, extracted from on date 2020 1204, and it's 08:40 p.m., right? So, I don't know, maybe that's not enough information, right? Like, maybe we should write comment extracted from. I think we're just going to assume we're smart enough to make the loop, make the assumption that when I say extracted from, I'm talking about this, and we know that these are just comments, so I don't think we have to write comment extracted from, and we're running out of column space, so we need to be terse. So I think that's good enough, and just so we have a history of like where did this come from, right? Then back in here, we just can say pattern breaker pix name, and that's good for me. Now, do we need to do we need any indentation? Like, why do we have all this indentation? Is this indentation necessary? I don't know if it is. But we'll keep this indented over here. Okay, yeah, so I see what we're doing here. So this is also kind of weird where this is just supposed to be a repository of all of the names of the different chunks of data we're using. But we're also going to keep the texture slots here as well, right? And we're going to keep these texture slots. We're going to keep that same one-to-one relationship where editor 1 uses texture slot 0, editor 2 uses, well, actually, hold on. We really should avoid using texture slot 0. And the reason for that is just out of simplicity, where there is no editor 0. There's editor 1, 2, and 3. So to keep everything simple and keep everything easy to follow, I think that texture slot 1, texture slot 2, texture slot 3, etc. This 1 also corresponds to the number key 1, number key 2, number key 3, right? Keep a one-to-one relationship with all of that stuff so it's really easy to track. The other thing is sometimes when you forget to initialize or set something up, like you cal-locked some memory and then you forgot to set it up, you're going to end up with a 0. So that means that if we have this as texture slot 0, we could end up with errors because we could end up with things working when they shouldn't be working because, well, we forgot to set this value, but its value is coincidentally 0, which is coincidentally from a cal-lock, right? So there's a lot of problems with using 0 for meaningful data, so I like to keep 0 as a value for uninitialized or undefined, just so that I can avoid stupid mistakes like that. So we're going to keep this like that. So just make a little note of that there's keypads here. And I'm going to make a note that so I'll do keypad So we'll make a little note here for what the hell we mean by that, right? And we'll try to, when we put pound signs around any comment, the idea there is to state that that we can find that comment, we can find more information about what we're trying to say in another file, right? So we can keep our commentary very terse in where we have the code and kind of offboard it into a different file. So we could do 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9. The thing is associated with editor number 1, keypad 1, right? And so this is all we mean. This is all we mean. We're trying to keep those one-to-one relationships, right? And we're just, yeah, we are going to be very explicit here, because this is where we get to be as explicit as possible, and the pattern is kind of what I want to see, right? Keep those one-to-one relationships. Also, we had a commentary where we kind of talked about those one-to-one relationships earlier. And so we can also, you know, reference, you know, see, right? So that's kind of what I want to say when we are looking at the pixel name. Actually, let's reload this. Yep. So let's reload that. So when we're talking about the pixel name slots here, right? This is what I mean why we have 1, 2, and 3, and this is 1, 2, and 3. And that's just to make it easy to follow. Just keep the code as regular as possible so it's very easy to follow. So a bit weird, but let's keep the texture slot values centralized here as well so that we can easily verify all texture slots are unique. So that's a comment for this. So this comment here, I don't know where that needs to be. This almost seems like it should be like something above here at the very least. And then we have all these things here. So what we could do is dash line I0x64. We could segment these chunks in kind of a logical way. I think that's not too bad, right? And then that comment above here can be, you know, a minimal amount of commentary is okay. We just don't want to be too verbose about it, right? So change later when ready to use. I'm okay with that, but I would like to do snake case, or not. Let's convert it to uppercase, or no. So let's do TLCMD. We're going to convert that to lowercase. Then we're going to convert it to snake case, and then we're going to convert it to uppercase. There we go. And then we'll do that. And that's just so that when I click on these, I can see both of them at the same time. Anywhere where I use that, I can see that. And it's not a hashtag comment, right? It's just a one-line comment that has been duplicated. And whenever I duplicate a comment verbatim, I like to keep underscores between it just because it makes it really easy to identify where that has been duplicated, right? So right here, this should probably be pretty obvious. It's just a visual checksum to make absolutely sure that there's exactly those number of slots. And let's take this comment and why texture slots in pix name, right? So no, honestly, you know what? I think that it would be a little bit easier to read if we start doing it like this. We have like a little underscore there before the hash. But why texture slots in pix name, right? So if we look at text slot and you're like, what the hell is that? Well, now this comment kind of gives you a little hint that text slot probably means texture slots, right? And then we can take this little commentary and we can go back to our hashtag file. Let's make sure that these are both synced up. Let's go to our hashtag file and we'll edit it over here. And we will put that commentary in there as well, right? So you might be like, oh god, this is a whole bunch of work, get to the code, why are you doing this? This doesn't seem right. And you know what? I think that the code is the easy part. Remembering why you wrote the code and like how the whole project goes together, like that is the hard part. But like any small piece of code, that's actually the easy part. I think getting your head wrapped around an entire project, that is the most difficult part as far as I'm concerned. Right, like I can solve coding challenges on like Code Wars like all fucking day, you know? But when it comes to like a big project and trying to put things together, you know what? I still don't know what the fuck I'm doing. I keep on experimenting. I keep on making things, breaking them down. So I'm convinced that that is the really hard part. So why texture slots in pix name, and also we might want like another divider just so that we have and if we want to have some type of, now that indentation that we have is kind of like now we have kind of a logical reason for the indentation in the first place. We might want to use a different kind of comment style here at the top of the file, just so that we can, just so that in that hashtag, right, we can get rid of the comment characters around this if we do that, and then we can do pattern breaker pix name, right, and then when we look for this, we can go Control F over here and be like, what the hell do we mean by that? And we can see, oh, there's a section for it right here, pattern breaker pix name, and we have like all this stuff, right? The comments are the last thing you're going to read, so we shouldn't, since they're the last thing you're going to read when you're looking at the code, we might as well, you know, not have all of these lines of code here, right? We should just have this little thing of code and a easy way for people who are new to the code base to figure out where the hell this is, right? And figure out what that convention is. So let's, so I like that little cleanup, like this looks a lot nicer. Now, do I remember why I was looking at this? Honestly, I don't remember why I was looking at this. But before we go, let's, do I want to reload it? Yes. And I kind of said that I was going to keep all the data on this side, so that was bad of me to open it on the wrong side. Let's open the pixname functions, and I assume there's not any pixname functions, but for the consistency of the project, I created a pixname.f, even though there's no associated functions. So if you go into pixname.f, well, I was wrong. So init str cmp paint 5d to do. Okay, yeah, so that's just me adding a little bit of checking to make sure that these names are exactly what they should be. That's just a little redundancy, right? Just a little redundancy so that if the file is accidentally edited in the data file, we have a little redundancy to help catch that problem, right? And that does leave us with less flexibility, but we're trying to, we want clarity more than we want flexibility in our code, right? We don't really care about flexibility. I think flexibility is a misnomer. if you have a fundamental design flaw in your code, good fucking luck refactoring that out after you've like created, you know, thousands of lines of code. Like, good luck. So forget about flexibility. That is a red herring as far as I'm concerned. And yes, I am very opinionated on that. I think that people think that just because this is digital, that it's somehow more fluid than, say, something physical like a house. But I think code is more like a house. It's like it would be like you wouldn't say that a ZBrush sculpture is somehow like easier to refactor because, oh, it's a digital asset and you use digital tools on it, right? No, it's still just as hard to change as actual clay sculpture, as far as I'm concerned. I mean, there's some things that are easier, right? Like, you know, you can just change the color of things with like one variable change. So there are some things that are very flexible because it is code, where you have a lot of leverage in how you can make changes. But most of the time, I think that if you think about it as something very flexible, you're going to be shooting yourself in the foot. Functions do not belong here, data only. So that is true. However, that's the whole purpose of, like, this whole project is kind of like, you know, this whole project is all about that organization, right? So I feel like that is an unnecessary comment. We already know that. We can... This is a very common halt function. We use it in almost every single sublibrary, so there's no need to use up 2 lines for this. Now, if it was something that, if it wasn't a common function that is always the same code over and over again, it would make sense to stick this here, because we read things linearly, and you're probably going to miss this if you pack it on like that, because you're not expecting it. But for this code, for this function, because it is used in such a high frequency, I think we can afford to lack some clarity for the sake of just making the footprint of the function a little bit smaller. So init the sublibrary section. So we have a halt function. I think that I've been using H for halt a lot. I think that it would also... we're not really at a premium for space here right now, so I think that it would make more sense just to call this err, right? ERR. I think that's a little bit clearer. It's also the Fitts law kind of applies to this as well. It's just a lot harder to click something that's one token, or sorry, one character. The token is one character rather than the token being 3 characters. So I feel like that's just easier to work with. And if you're confused about what I mean by Fitts law, we can actually go over to look up Fitts law. So Fitts law. Fitts. I don't know if that's how you spell it. I think it's called Fitts law. If it's not, then I'm going to make a shortcut for it. So Fitts law. And let me go over to my over here. Actually, I need a left monitor. Whatever. So this is gonna look a little ugly until I Fitts law. Yeah, Fitts law, but no, there's no Z there. Yeah, so it's just talking about how difficult it can be to click small targets and the relationship between the distance and the size of the target, and how long it's going to take you to click it, right? And so I'm not really a super good math person, so I don't understand all of this. Really, you just need to realize that smaller things are harder to click, and if you want to say that succinctly, instead of saying smaller things are harder to click, you can just say Fitts law, right? So we're gonna take that, we're gonna put that into Fitts law, and then it's not really spelled like that, is it? It's called Fitts law. So Fitts law. Okay, Fitts law, Fitts. Okay, and so next time I try to look this up, I'll realize that Fitts is not spelled with a Z, and I'll be able to find that, reference it again. So let's close this. That's just, I just wanted to go over that really quick. Okay, so back to this code. We are just cleaning stuff up, and yeah, we just changed the H for halt to just ERR. Now, when we're really running out of space and everything's getting kind of really compacted, we will start using H for halt. Now, you'll see that the error messages are always between square brackets like this, and the reason for that is the most important thing about an error is knowing exactly where it came from, right? And the purpose of an error is to notify a human being of a problem and allow that human being to edit the source code and fix that source code. So forget about all that nonsense in Java, about all these different error classes, or even in C#, all these different error classes. That is a waste of fucking time. The only thing we need here is we need to know what's an error, and there needs to be a unique error message, and that error message doesn't even need to make any fucking sense. It just needs to be some type of a unique token that we can find in the code somewhere so that we can fix the problem, right? Now, you could argue, well, this is a lot of bytes to be in the text section of your source code. Aren't you wasting memory? And and for that, I'm just going to say blah, 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 premature optimizations, blah, 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 right? Okay, so that looks fine to me. That looks nice and clean. I'm good with that. So since we've been kind of like wandering around kind of aimlessly, and it might make sense to actually look at everything in a very linear order and actually do our cleanup task, you know, going through everything in order and just cleaning it up as we go. So before we do that, let's make sure I didn't do anything completely stupid and break the code. So we're just going to take a run on this and get this compiling really quick. Make sure that the project gets to where I think it should be, and we might also remove the vital to-do. We're going to remove the vital to-do really quick just to make sure that there isn't some other problem that we've introduced. And that the project works as I would expect it to. So we're going to remove the crash on vital to do right here, and then we're going to run our build script again. And if you'd like to take a look at what that build script looks like, we can open up that with Notepad++ really quick. And right, it's just a very basic script that has a lot of strictness for how things are put together, right? So I just want to compile as strict as possible. I want to compile as C11, and I do want to do it as a 64-bit executable, just because I'm on a 64-bit operating system. This comment is just for me. I have a snippet I reuse when I create these files. I don't type them all out by hand every single time I make them. So these notes seem kind of old because libsfml, this is like how to start up libsfml. Like, why are these here? GCC notes. Okay, yeah. This is kind of a weird thing to do, just have this like artifact comment of like stuff. But whatever, I'll keep it, because it kind of reminds me of if I ever use libsfml again, it's just some usage of the like how to properly use the linker when you're doing more complicated projects that have like dependencies that need more command line arguments, like how you do that. There's some notes on how that is done. That's fine. I'll keep that there. Also, the project is already started, so it starts by opening up a little color picker, which isn't really necessary to the project. You can turn off this feature later, but it's there. And then it tells you that you're awesome with a little pop-up dialog. And then supposedly a window was supposed to open, so now I'm kind of worried. So let's see, paint5d init fail on text slot. So I know I changed that texture slot index because I'm like, it really should be corresponding to the keypad number, and so I changed that. So let's go look at the asserts. I'm sure that we can find it in the function section of something or other will show us that. So let's find in files, and let's look for this exact error message and find where that is. Okay, and we see paint5d.f. So let's take a look at what the hell is going on here? Well, it's in paint5d functions, so I don't know why it looked like that, but okay, so we know it's in here, and we're probably looking at it right now, yeah. Okay, so that's fine, and I believe not equal to 0. Okay, so this is, we're just zeroing everything out first, I believe. Or is this GPU paint5d init? Okay, this is initting the data for paint5d. And this texture slot is 0. And if we look in our pixel name stuff, so if we open up pixel name stuff, so in our lib with pixname.data, we see these texture slots here. And do these texture slots, are they referenced in here? Okay, yeah, so yeah, that is where we're doing that. Okay, yeah, so that's all good. That we just gotta change this to a 1. And right, so the idea is that, right, this all looks very busy, and so to have this file over here, which serves as a really nice, concise summary of what the hell is going on, is nice, right? Because we're kind of lost in here just trying to fix this one problem, and all it was, you know, this texture slot needs to be 1, right? So now, if we go back and try to run the project, let's try to run the project again, and hopefully it doesn't give us a crash. Right, opens up a color picker, pick a color, whatever. Tells me I'm awesome, but I have multiple monitors, so you can't see that. And then we get this little default shader. And then if we press number pad 1, default 1, this I just stole from Shader Toy. It is not my code. But I just wanted to prove that I could get Shader Toy code to like execute on my current setup. And then all these default things here. So, and then another, I think this is just another default Shader Toy kind of thing. And the purpose of getting those Shader Toy things in here is because I've written some complicated Shader Toy code. I want to be able to test stuff out on Shader Toy and then be able to implement it in the game. And so this one right here, this is the default Shader 1. I'm eventually going to put all of the paint5d program code in here, and then this will be reserved for something else. This is not actually in the source code of my project. It's in those editable mod it's in the mod folder, right? So when we first run this project, it takes all these default shaders and dumps the source code into text files and puts them in the mod folder. It creates a mod folder wherever you run the exe, and then and now you can edit the source code of the game, right? So now, if you make a mistake editing the source code of the game, you can just delete the files, and then it will be like, oh, those files don't exist again, and it'll just read it from the disk, from the source code again. But yeah, that looks good to me. That's kind of like where we are with this. So really not much there. But I'm confident that we didn't break anything quite yet. So for now, let's keep the vital to-do thing. Let's keep that off. Let's not crash on missing a vital to-do, just to make sure that we can compile up to that working state, because it's absolutely imperative we have working code, because If we don't have working code, it's going to be even harder to figure out where the hell we are. You know, so okay, yeah, so that's good. Now I don't know about making this. This should probably be uppercase. I mean, it's a macro that's used in a very short span, so I don't know if it matters. I think that the reason I used all lowercase was because if I ever make a library struct called paint5d, then we can't have this be all uppercase. I think that is why I did it that way. I could be wrong. Okay, yeah, so let's go through everything in order. Let's close this, and I know I was well, we'll worry about the documentation for that later. We'll just go through everything in order for now. And yeah, let's just go through everything in order. So let's close this, and let's open up the documentation. What am I doing here? Let's open up the library, and let's just open everything in order. Now the thing is that everything has kind of been dumped in here, and there's no inherent order on these file names. And the reason why I don't have a number on the actual file names is because first of all, it's just a nightmare to memorize. Like, you need a photographic memory to really memorize. If you gave all of these a unique prefix number, then you'd really need, like, a photographic memory if you wanted to, like, come back to this project a month ago and have all those numbers make sense. And I have an example of where I did that. Like, I did that in one of my Vulkan projects. So if we go into, do I have the V drive over here? So V drive, so VKG, Vulkan Glob. So one of these projects, I tried to do something like that. Not this one. But nothing in there. Okay, so this one. So this one I tried to, like, give everything, be very terse, and just be like, this is file 1, this is file 2, file 3, file 4, and give every file a very strict order, and then just compile them in that order. Well, now the problem is if I ever want to insert something, like I forgot that between 61 and 62, in retrospect, we really needed something between that, right? So we have to create a 61.05, right? Originally, I was just, like, renaming everything, like, oh god, let's just rename this to 63, rename that to 64, rename this to 65, do that for all the files, and then create a new 62, and that was a fucking pain in the ass. It was just an administrative nightmare. And then also, when you look at this, you have no fucking clue what any of these things do by just glancing at it, which was kind of the intention. The intention was, you know, you gotta look at the documentation to figure out what all those numbers do. Oh, hey, no documentation to tell me what those numbers do. I guess I have to actually open up the source code. So do one thing and do it well. Initialize any libraries that need initializing that were added to the project. Okay, interesting. And if we look at, let's just look at some of this other stuff. So FO3, what is FO3? Okay, do one thing and do one thing well. DLL call cast. So the idea of having very small modular units that do one thing and do one thing well, and keeping a very linear order for how that is all done, I think that's a great idea, right? Do one thing, do it well, right? DLL, wrapper, boilerplate, right? Like, and then, you know, having a very definite order of how all of that code appears. Do one thing and do it well. Snap chain view. So create snap chain image views, and so, you know, that's actually not a bad way to go about it. But so having a definite order, keeping every unit very small, that's good as far as I'm concerned. But the bad thing about this is just the fact that everything is, it's an administrative nightmare. to work with files like this. It is nice that, right, like F36 probably has a namespace. Yeah, so everything has like a F36. So in the F36 file, you have this F36 in front of everything. And so you have this nice little terse namespace for everything. And when you're looking at code, if you see another number, you know exactly where that came from, right? And that was really nice, right? Being able to know exactly where everything came from. But this was too terse of a solution, right? So rather than being super terse like this, it's like we're going to use a little bit longer of names, but have some type of meaningful name. And that's the way we're doing it now. So this is crazy. So I'm going to take this and just, let's see, is this in a repo right now? So VG has a git repo. Okay. Name numerically. So I'm going to take this and I'm just going to make some notes about this. Numerically named source files. Oh, I gotta go upstairs. That was my timer. Okay, I'll be right back. I just gotta turn the, actually, no, I'm gonna go for now because I have food, and then I'll be back after I'm done with my food. Yeah, that's what's gonna happen. Okay, so see you later.